calculus, one of the most difficult parts of your curriculum. However, very much doable. Let's break it down. A function is defined for x belonging to R by, and then we have a function given. We can identify that we have elements of quadratic function. We as well have a trigonometric function. Okay, so what do we need to do? Find f prime x, which means what? The derivative of f with respect to x. That's basically a word explanation of what that description means. That's all what it is. How do we derive? Oh, before we even go into that, let's have a look what's actually derivative is. So the graph of this function, now let's have a look. I know you don't have to actually know the graph of this function, but I just want to use that as an opportunity to explain. So that's the way this function look like. A bit like quadratic, but as well a bit wobbly like trigonometric function. So if I am to describe this line, this curve, because not a straight line, I would say here in the beginning is pretty steep, is going down, then it kind of have a bit of a curve here, kind of like a D, but not fully. Then again it's going down pretty steep, then here almost is flat. Then I can say that, for example, here is changing the direction, is going up, and so on and so on. I can explain that. So derivative describe how the curve is changing. Now, in maths, we know we describe things with signs and numbers, and that's what that description is, that we pick a particular point and we are saying at this particular point, the slope of that line is whatever value. That's what the derivative is. The value of derivative is the value of the slope at that particular point. Anyway, back to our question. So how do we derive? We derive each element separate. How do I know how to identify elements? Elements are divided by plus and minus. Not by multiplication or division, that's a different thing, by plus and minus. So if we are working already on calculus, we know, but if not, a number that doesn't have x beside it, doesn't have our variable, that number will become 0 in the process of differentiation, of creating that derivative. Then for those two elements, we're going to apply formulas. What formulas? We go to our maths table, and that's page 25, if I'm not mistaken. That's where we have this is where we are looking for our function, our element of a function, and this is the formula that will tell us how to change that element into derivative. So that's what we have. First, we have x to the power of 2, so that looks exactly like our formula, where we identify that n is 2 in this particular example. So that means I'm going to have 2 here followed by x, then 2 again, minus 1, therefore 2x to the power of 1. That's simple enough. What about here? Now, the problem we are having is that we don't just have x. We have 4x here. So what do I do with it? Well, at first part, I am deriving it exactly using that formula, but instead of x, I am putting what I have in that place. So that means that will be cos 4x. However, I cannot not ignore the fact that I have more than just x there. Now, 4x in itself, it's a function. It's a very simple linear function. Okay, so again, what does that mean? That means that we need to multiply that by the derivative of that function, or derivative of, usually that will be in the bracket. That's what we do. So in this case, derivative of simple 4x will be 4. Yeah, so that's what I'm saying. We are applying chain rule. It sounds more difficult than it is, because applying chain rule in case like that, we are multiplying by the derivative of the function within. Okay, so let's put that together, our derivative. Now, if you ask me, 2x to the power of 2 plus 4 cos 4x. If you ask me, how do I know that, how do I recognize how, in what situation do I apply chain rule? If you look at those formulas in your table, you will know that every time you have single x, that x doesn't have anything beside it. So when in your function, like in our case, we didn't just have x, but we have 4x, that's how you know, basically, yeah? You can recognize that it is a function within a function. Okay, then let's have a look at next part of this question. So part 2. Find the equation of the tangent to the curve at a point where x equals 0. By the way, I just want to show you, for the curious mind, here is the graph of our function, and this is a graph of the derivative. Yeah, looks very strange, I agree. Okay, anyway, that was just to kind of satisfy if you are curious about how does it look like. Okay, so back to our question. So we are looking for the equation of what? Of a tangent. What is tangent? It's just basically a straight line that is touching a curve at a very specific place. Equation of a line. How do we do that? In our table, we have a formula that has to do with equation of a line. Oops, past that. That's where it is. I know we have two formulas, but by default, we can go always for the first one because rarely we have information for the second one. Therefore, y minus y1 equal mx minus x1. So I'm asking myself, like with every formula, well, what do I need in order to use it? Every function have x and y, right? Just to say that y and that x will remain as y and x. The rest of the stuff have to have numbers in it. So y and x represent a point that is on the line, and then m represent the slope. So now my question is, do we have this information? Well, here they are saying that we are looking for the equation of a line of the tangent that is touching that curve at x equals 0. Actually, since we have our graph, let's consider that. So here, so let's get, this is the place where x have 0. So this here, oops, again, let's see whether we can get a line. Now, my line is not very, because it should be touching the curve, not cutting through it. Oh, okay, no, I can't move it. Oh, yes, there it is. So more or less, it is a line that will be touching. So I am looking for an equation of that line. Okay, so that you have an idea, it has to be at a very specific point. Now, that point, so we understand, again, back here, so we understand that this will be the point. Now, what are the coordinates of this point? Well, I know the graph look like, however, we cannot go by the graph and we don't do the graph in the question. So we know that the value of x will be 0. We just don't know what will be the value of y, isn't it? However, that point is common. It belongs to the curve and it belongs to the tangent. It's a point that belongs to two of them. So since it belongs to two of them, well, I can use that to find the value of y, isn't it? Since I have the value of x. So my function f, when x equals 0, would be what? 6 plus 0 to the power of 2 plus sin 4 multiplied by 0. And we put that in the calculator, make sure that, yeah, no, actually it doesn't matter. It can be in degrees. We put that in the calculator, and what do we get? We get 6 here. So we know that the point we are looking for, that value of x is 0, value of y is 6. So then we are only left with the slope. So how do I find the slope? And that's when that knowledge comes in. And the knowledge that we very often apply in the question with calculus is the fact that the slope of tangent is the same and unequal to value of derivative. Obviously, slope of a tangent at a specific point is equal to the value of derivative at the same point, because it has to be the same place. Okay, so that's how we're going to get the slope. That knowledge, application of that knowledge, extremely common in your exam, especially in a small question. Not in the big one, but in the small question. Okay, so I need to find a derivative, the value of my derivative, meaning the value of y, at what point when x is 0. So I'm saying my derivative when x is 0, that was 2 multiplied by x is 0, plus 4 cos, and then 4 multiplied by 0 again and again. We put that in the calculator, and what we will get, that will be 4. So that is the slope. Therefore, now I have all the elements, I can fill them in. Y minus the y coordinate of a point, which is 6, equal m, slope is 4, multiply bracket x is x, minus the x coordinate of a point, which is 0. So, oops, that ran away. Okay, so that means y minus 6, 4 multiplied by x, that's 4x now, 4 multiplied by 0, that will be 0. Again, we've done that. What do I do next? I look at the terms and condition of my answer. And the term and condition of my answer is all elements on one side of the equation, nothing on the other side. And then value of a, b, and c have to belong to z. If we don't remember what z is about, we can always open our maths table to page 23. We look at the numbers and we know they are the whole numbers, positive and negative. So moving it to one side, doesn't matter which side. I can move to this side, that 4x, go to the other side, therefore change the sign. Or I can do the other way. I can move the rest of the values and change the sign, whichever way, doesn't really matter. And yes, the condition are fulfilled. All those numbers are positive, are whole numbers.